Simple harmonic motion. Simple harmonic motion. One of the simplest type of oscillatory motion is that of horizontal mass spring system as shown in figure. Initially the mass m is at rest position, that is at mean position O, and the resultant force on the mass is 0 as shown in figure. If the spring is stretched or compressed through a small displacement x from its mean position as shown in the animation, it exerts a force F on the mass. According to Hooke's law, this force is directly proportional to the change in length of the spring, that is F is equal to minus kx, where x is the displacement of the mass from its mean position O and k is a constant called the spring constant defined as k is equal to minus F over x. The value of k is a measure of stiffness of the spring. Stiff spring have large value of k and soft spring have small value of k. As F is equal to ma, therefore k is equal to minus ma over x, or a is equal to minus k over mx, or a proportional to minus x. It means that the acceleration of a mass attached to a spring is directly proportional to its displacement from the mean position. Hence, the horizontal motion of mass spring system is an example of simple harmonic motion. The negative sign means that the force exerted by the spring is always directed opposite to the displacement of the mass. Because the spring force always acts toward the mean position, it is sometimes called restoring force. A restoring force always push or pull the object performing oscillatory motion toward the mean position. Initially, the mass m is at rest position, that is at mean position O, and the resultant force on the mass is 0. Suppose the mass is pulled through a distance x up to extreme position A and then released. The restoring force exerted by the spring on the mass will pull it toward the mean position O. Due to restoring force, the mass moves back toward the mean position O. The magnitude of the restoring force decreases with the distance from the mean position and becomes 0 at O. However, the mass gains speed as it moves toward the mean position and its speeds become maximum at mean position O. Due to inertia, the mass does not stop at mean position O but continues its motion and reaches the extreme position B. As the mass moves from the mean position O to the extreme position B, the restoring force acting on it toward the mean position steadily increases in strength. Hence, the speed of mass decreases as it moves toward the extreme position B. The mass finally comes briefly to rest at extreme position B. Ultimately, the mass returns to the mean position due to restoring force. This process is repeated and the mass continues to oscillate back and forth about the mean position O. Such motion of a mass attached to a spring on a horizontal frictionless surface is known as simple harmonic motion. The time period t of the simple harmonic motion of a mass m attached to a spring is given by following equation. T is equal to 2 pi under root m over k. For more videos, watch YouTube channel TheScience.Pk.